second question. Finding the quadratic polynomial each with the given numbers as the sum of and the product of its zeros respectively. Okay. So in the question, they are given sum of its zeros value and the product of its zeros value, and they want to ask us to find the quadratic polynomial. Okay. Let us consider ax square plus bx plus c, which is the standard quadratic polynomial which are having alpha and beta as zeros. Okay. So given alpha plus beta is equal to 1 by 4, which is equal to minus b by a, and alpha beta is equal to minus 1, which is equal to c by a. So while comparing the given values with the coefficient terms, we are getting the values of a, b and c as a is equal to 4, b is equal to minus 1 and c is equal to minus 4. So if we know the values of a, b and c, we can easily write the general equation as ax square plus bx plus c, that is 4x square minus x minus 4. So it is a resultant equation. Okay. Now, second question. The given sum of its zeros as root 2 and product of its zeros as 1 by 3. That is, given alpha plus beta is equal to root 2 and which is equal to minus b by a, and alpha beta is equal to c by a, which is equal to 1 by 3. Okay. So we know that if alpha plus beta and alpha beta values are given, then if you want to find the general equation, we know that the general equation is k into x square minus alpha plus beta into x plus alpha beta. Here k is called constant. Okay. Now if you substitute the alpha plus beta value and the alpha beta value in the given equation, we are getting x square minus square root 2x plus 1 by 3 is equal to 0. This implies 3x square minus 3 root 2x plus 1 equal to 0. This is the required quadratic polynomial equation. Third, 0 comma square root of 5. So given alpha plus beta is equal to 0 and alpha beta is equal to root 5. Okay. We know that the general equation when alpha plus beta and alpha beta are given is k into x square minus alpha plus beta into x plus alpha beta is equal to 0. Hence, if you substitute the values in the general equation, we are getting x square minus 0 into x plus root 5 equal to 0. So this implies x square plus root 5 is equal to 0. Next term, 1 comma 1. Given alpha plus beta is equal to 1 and alpha beta is equal to 1. So the general equation is x square minus alpha plus beta into x plus alpha beta is equal to 0. If we substitute in that, we are getting x square minus x plus 1 is equal to 0. Okay. Fifth sum, minus 1 by 4 comma 1 by 4. Okay. Given alpha plus beta is equal to minus 1 by 4 and alpha beta is equal to 1 by 4. And we know that the general equation when alpha plus beta and alpha beta are given is x square minus alpha plus beta x plus alpha beta equal to 0. Then if you substitute the values, we are getting x square minus 1 by 4 into minus of minus 1 by 4 into x plus 1 by 4 equal to 0. So if you multiply 4x square plus 4x plus 1 by 4 plus 1 is equal to 0. Okay. Now, sixth problem. 4 comma 1. Given alpha plus beta is equal to 4 and alpha beta is equal to 1. And the general equation is x square minus alpha plus beta into x plus alpha beta is equal to 0. Okay, if you substitute the values alpha plus beta and alpha beta in the given equation, then we are obtaining x square minus 4x plus 1 equal to 0. This is the resultant required polynomial equation. Okay. Use an algorithm for polynomials. Okay. We know that a cubic polynomial has at most 3 zeros. So that we are getting 3 zeros for a cubic polynomial. We can know how to find zeros for a quadratic polynomial. Since quadratic polynomial has at most 2 zeros, we know the process of how to get zeros for quadratic polynomial. But now cubic polynomial, it contains 3 zeros at most. So if one 0 is given, then can you find other two? Yes, it is possible. How? In the sense, if a particular value becomes a 0 for given polynomial, that means the factor, that is x minus that particular value, is a factor of the given polynomial equation. So if you divide the factor with that given polynomial equation, then we are getting something as a coefficient. Now a coefficient, if you look clearly, we can clearly say that it is in the form of a quadratic equation. Now for quadratic equation, we can know how to find the zeros, like by splitting the middle term and we find the factors. So now we get 3 zeros by using this division algorithm for polynomials. Okay, let us see some example to understand the concept, right? See, example 6. Divide 2x squared plus 3x plus 1. So, they are asking divide 2x squared plus 3x plus 1 in that with x plus 2. So, do you know how to do division process? So, first we have to check what is the power of the divisor and what is the required power of dividend. So here I can clearly say that here the power of dividend is x squared. So here I am having x. So if I want to get 2x squared, I want to multiply this term with 2x. So that 2x into x, which is becoming 2x squared. So I am taking 2x as coefficient. Then if I multiply 2x with this total term, I am getting 2x squared plus 4x. So now we want to change the symbols. Here these two symbols are positive. So I am changing this to negative. So I am making subtraction. Now we are getting minus x and we are borrowing down this term plus 1. So now it becomes minus x plus 1. So here now the power of here is 1. And also the required power is 1. So just I want to change a reverse sign so that I am getting minus x. So I want to multiply with minus 1. So if I multiply this whole term with minus 1, now I am getting minus x plus 1, minus x minus 2. Then again I want to change the symbols. Now here already it is minus, so I am changing it as plus, and here also it is minus, I am changing it plus. Now I am getting 3. It as a remainder. Note, we have to stop the division process when either the remainder is 0 or the degree is less than the degree of divisor. Here the degree of divisor is 1, but here degree of divisor is 0. So the degree of remainder is less than when compared to degree of divisor. So I can now stop the division process, and I am writing that 2x minus 1 into x plus 2 plus 3, which is equal to 2x squared plus 3x plus 1. So that is 2x squared plus 3x plus 1 can be written in the terms of factors as x plus 2 into 2x minus 1 plus 3. Therefore, dividend is equal to divisor into coefficient plus remainder. So this is the same rule we can applicable in terms of cubic polynomial when one factor is given. See, let us see some more examples.